Homework 3.7, number 31, 40, and 53. Number 31 says measurement of the side of a square floor tile is 10 inches with a possible error of 1/32 of an inch. So I drew the floor tile right here. I drew the floor tile right here. And because I know the error is 1/32 and I know the area of this floor tile is 10 by 10, so that means it would be 100 inches. And so I use the function y equals x squared, and then I use the derivative y d over y x. I find the derivative of this, which I use the power rule, which is the 2x. Then I find the differential of that just by multiplying by x. 2x times dx equals dy, and then since I know dy is the error that it's gonna be like the possible error, and I know dx is the error. I mean, it is the possible error of 1/32 plus or minus. And then I plug in 10 because that's the length of the side for x, and then I solve for that to get the fraction or the to find the answer. And the answer is plus or minus 5/8 of an inch, and then that's what A asks me. And then B is asking me to find the percentage, and to find a percentage I use the derivative of y over y. So derivative of y, the function, is 2x, and then over y, the function is just x squared, so it's 2 over 10 squared times plus or minus 1 over 32, and that equals, because that's the percent error, that's 20 over 100 plus or minus times plus or minus 1 over 32. That equals 0.00625 or 0.625%. Alright, so for question 40, it says use differentials to approximate the value of the expression. This is the cube root of 26. And so first off, I gotta make the guess I know, or something close to 26 that I know the cube root of, and that's 27, and that's 3. And then I need to find the derivative of f of x, which equals the cube root of x, which equals 1. Well, since I know the cube root of x equals 1/3 x to the power of 1/3, then I find the derivative using the power rule, so it's 1/3 x times negative 2/3. And then I use this formula to figure out the approximate value, and so that's f of c, which is the guess. F of c is 3, so f of 3 plus f prime of c times x minus c, and x is what I need to solve for, 26, right there, 26. So I plug in the values. F of 26 equals 3 plus 1 over 27 times negative 1, because 26 minus 27 is negative 1. And then I solve that more, and I just put stuff together, and it should get me 80 over 27, or about 2.963. And then 53 says the profit of P for a company is P equals 100x e to the power of negative x over 400, where x is the number of units sold. And A is asking me to find P prime, or the derivative of P. And the derivative of P in this case would be 100. Well, I have to use the product rule, so 100 e to the power of negative x over 400, because find the derivative of 100, and then I have to use chain rule, so e to the power of negative x over 400 minus, negative 1 over 400 minus 1/4 times 100x. And then I simplify that down further, and then I should get 1/4 times e, because they both have e to the power of x over 400. And so I do 1/4 times e to the power of negative x over 400 times 400 minus x. Now it's 400 because 1/4 times 400 is 100. And then B asks me to find how many units produce a maximum profit of P. And so what I do is I plug 0 in for that, right? And this cancels out when 0 gets added to x. And then I solve for this right here. So then 0 equals 400 plus x. X is about 400. X is 400. And then for C of this problem, It says approximate the change and percent change in the profit as sales increase from x equals 120 to x equals 130 units. So first off, I used a derivative of x equation. I plug in 120, and that should equal 51.86. And then I plug 51.86. Wait, never mind. That equals 51.86, right? And then I plug f derivative of f of 30 into this, and then that should equal 48.77. And then I take each of these values and plug them into the original f equation. So then the original f equation would say that for the 51.86, it equals 3,581.16333, and the second equation, f of 48.77, that would equal about 31,091.29877. And then I subtract the f of 48.77 minus the f of 51.86, which equals a change of $510.13. And then to find the percentage of that, I do the same thing over here with just one of the values, 120 or 130. In this case, I used 120. I used the formula that I used in problem 31, so differential over original, so f prime over f, and then that should get me 5.8%.